All right, so today we're going to be solving a system of equations using matrices, okay? And so how we solve, it's going to look like this, okay? C will be our solution, and so to solve for our two solutions for x and y there, it's going to look something like this. It's going to be A inverse times B. That's our formula every time, okay? So like when we look at this first example, the first thing we're going to write it as a matrix equation. What does that mean? It looks like this. So this left side here, you're just dropping your x and y's. It's going to look like this. So we're going to get a 2 by 2 here where we have 4, -7, -6, -9. We always put an x and y here. And then just equal to our numbers on the right side. So that's always the first step. Okay? I'm going to be honest with you guys, like, that's going to be a great test question, a great multiple choice question. Hey, is just to write this system as a matrix equation. What would that look like? Okay? Now, why am I doing A inverse? Well, the thing is I wish we could just go ahead. How would you isolate? You know, we learned it yesterday in elimination, but whenever we're like isolating variables, usually what we do at the end here is like when we have something like this, right? We have 4y = 16. How do I solve for y? I'm going to divide everything through by 4, right? And I get my solution. Well, unfortunately, that is not possible. Okay? That is not possible with matrices because we cannot divide. So what we have to do then is we have to then, to get this over this other side, we have to take this original matrices and find the inverse and then multiply it by that. Okay? So my next step then is I need to find the determinant of, oh, I'm sorry, let's label this. This is A. We just call this X here above, even though it's a double X, and then this is B. Sorry. And so that's how you're going to get, and then C is going to be our solution. So the determinant of this would be what? It would be 4 times -9, which is a -36. -6 times -7. Minus sign here, though, is a +42. And so, yeah, this is a little ugly here, but that's okay. So -36 minus 42 means our determinant then is going to equal, I can't think of that off the top of my head, I'm sorry, -78. Now, what that tells me then is that, yes, I'm able to keep going here because that matrices has an inverse. If for some reason I was able to get if I got a 0 for my determinant, then the system is no solution. It's just not possible because I don't have an inverse. Recall that, right? So a singular matrix is one that has determinant equal to 0, which means it's singular. Non-singular is when we do have an inverse. So singular is when we don't, non-singular is when we do. Okay? All right, so now that we've done that, we need to go ahead and we need to find the inverse here. So how does it look like? It's going to be like this. So we're going to have now 1 over the determinant, so -1 over 78, times, remember what happens here, I flip A and D, so -9 and 4, and then I just change the signs of C and B here to be positive, positive. Now, normally I would say, okay, you need to go ahead and you need to distribute this through to this parentheses, okay, to this matrices, but it's going to give you ugly, ugly numbers. So what I want to do first is while I have these nice whole numbers here, I'm going to go ahead and I'm going to multiply these two together. Okay? So let's go ahead, let's multiply those together first. Again, row 1 times column 1, row 2. So what do we have here? We have a 2 by 2 and a 2 by 1. So that means my solution between these two is going to be a 2 by 1. So don't forget about the -1 over 78. We're going to move that over here. And now we are going to have a 2 by 1 here. So row 1 times column 1. So -9 times 27. I can't think of that off the top of my head. So let's do that. So -9 times 27 is a -243. Remember, we have a 2 by 1 here, right? So 2 rows, 1 column, so negative 243. And then we have to do 7 times the negative 21. Minus 147. And then we'll come back and simplify that here in a second. So all I did, guys, again, remember multiplication, row 1 times column 1 here. Negative 9 times 27, 7 times the negative 21. Now we're going to go row 2, column 2 here. So 6 times 27 is 162. 4 times negative 21 is a negative 84. Okay? So again, how do we do that again? Row 1, row 2, column 2. Column 1. Row 2, column 1. 6 and 7 are first in their row and column, so they multiply together. 4 and negative 21 are second, so they multiply together. So let's go ahead, let's simplify this. So now I'm going to have a negative 1 over 78 times a negative 243 minus 147 is going to be a negative 390. And then 162 minus 84 gives me 78. And so now, last but not least, we're just going to do our scalar multiplication, right? So when I do negative 1 over 78, so if I do so if I multiply the negative 1 over 78 by the negative 390, I'm going to get this. And this is where you use your calculator again. So negative times the negative 390. Okay, that's going to give me 5. And then a negative 178 times 78 is going to give you a negative 1. Okay, and so then our set looks like this. Actually, you can write like that, or it's just really easy. I'm sorry, guys, I don't care. You can go, you just say x equals 5, y equals negative 1 again. How do I know which one's x and y here? Look when we write our matrix equation up. X goes first, y goes second. So that's how you know this number is always going to be x. That's always going to be y, and there you go. You solve for it. There's your solution right there. So it's a lot easier multiplying these two together first, then distributing the scalar, because the scalar is going to, you most likely times going to be an ugly fraction. Okay? All right, let's go on to the second example. Again, I want to write it as a matrix equation. Get used to that. Start doing it for all the problems so you do not miss an easy question like that on the test. And so you're going to get this. You're going to just drop in the x and y. So 5, negative 2, 3, negative 6, times xy. Okay, and there we go. So there's my matrix equation. So I took my system and it changed to a matrix equation. So now the next thing is we want to find the determinant. Again, I'm looking at A. Here's A. Just call this X, and there's B. Okay? So our determinant, 5 times negative 6, negative 30. Minus sign, 3 times the negative 2 is a negative 6. But remember, you got that minus sign already there for the formula. So that means your determinant then is going to be negative 30 plus 6. So it's going to be negative 24. So yes, we can go ahead and solve for the system because we did not get a determinant of 0. Okay? So let's go ahead here then. Let's set up our formula again. So remember, it's always 1 over the determinant, and then you got to flip some stuff in your A matrix. So we're going to have negative 1 over 24 times, remember, A and D just swap positions here. So -6, 5, and then 3 and -2 just change signs. So -3, +2. Okay, again, I could go ahead and distribute this through, but I'm going to get some ugly fractions. It makes the multiplying a lot harder to do. So again, just bring down the B value and just say, okay, hey, we're going to multiply A times B first, always. And I don't know why for the B value, I'm really sorry. That should be 10 and -18. I apologize, I was looking at the left equation there. So make sure I got everything good. So I flipped it, switched signs. Okay, we're good to go. So now we're going to multiply that by 10 and -18. And then it's going to look like this. You're still going to bring your scalar over, so 1 over 24. Again, because it's a 2 by 2 system, we have a 2 by 2 here, 2 by 1. That means my solution matrix is going to be a 2 by 1. So I have 2 rows. One column, and here we go. So row 1 times column 1. Row 1 times column 1. So -6 and 10 are both first there. So -6 times 10 is a -60. 2 times a -18, -36. Okay, now we're moving on to row 2, column 1. -3 times 10, -30. 5 times -18. Can't think of that off the top of my head. Oh, that is, 5 times -18, that's going to be 90, -90. All right, so let's go ahead now, and let's simplify this here. So again, bring your scalar down, so you have -1 over 24 times -60 minus 36, that's a -96. -90 minus 90 is a -120. If we're doing this right, we should get some nice answers here. And every now and then you might have a fraction as a solution, but I try to make them nice. So when we do 1 over 24 times the -96, since they're both negative, it's going to give you a +4. And then I'm assuming, because 96 is -120 is 24 higher than 96, I'm guessing it's going to be a 5, but let's just do it anyways. So when we multiply -1 over 24 times the -20, you're going to get a 5. Okay, and so there you go. So that's 2 examples there. Let's go ahead and write out our solution. So x equals 4. Y equals 5. All right. So there's 2 examples there. I know it's a lot of practice problems. Okay, but again, this can be a tough topic if you're not. If you're not putting in the work. Okay? So that is it for me today, and I will talk to you guys in class tomorrow. Thanks.